So the first rule of exponents looks like this: x to the n times x to the m. So what you're looking at here is that there are two bases. The base is the big number that has the exponent. So the big number is called the base. So we've got two bases that are the same, and when that happens, we add the exponents. And I'm just going to write the rules down, and then we'll do a few examples for each of them. So here this would be when there are two bases that are the same, but we're dividing. What do we do with the exponents? Subtract them. And I often think of this one as a canceling, and we've done this before. If there are four threes on the top and two threes, then they cancel in pairs. 3 over 3 would equal 1, so we're left with 3 squared. Okay, so I often think of that instead of as subtracting the exponents as canceling out the ones that don't match. That also could go the opposite way. If we had, say, 4 cubed over 4 squared, there's 3 4s on the top and 2 on the bottom. So how many of them would cancel? 2, and how many would you have left? 1. And I actually meant to do this. What about this way? 3 on top, 5 on the bottom. How many cancel? 3 of them. But how many do you have left? 2, but they're on the bottom. So we would write this as 1 over 4 squared. Right? If you cancel everything off the top, we're left with a 1. So you'd have a 1 left on the top and 4 times 4 on the bottom. You could write that as 16, of course, but I'm just showing you exponents. These more likely would be variables than they are to be numbers that you could work out. Okay, number 3. When we've got two exponents, one base, but the exponents, sometimes they look like this, you would multiply them. So there's lots of, so m times n, like that. And then 4, if you've got two numbers that are multiplied and the exponent is applied to both of them, so they're in a bracket, you can apply the exponent to each piece individually, and that's the same goes for division. Sometimes the one that confuses people here is if we had, for example, 1 over 2 to the 5. This is 1 over 2 to the 5th, but it's really 1 to the 5 over 2 to the 5, but 1 to the 5 is just 1 times 1 times 1 times 1. So people will sometimes ask, where did that exponent go? And it actually is in a circumstance like this. It's more, say, 1 over sine x all squared, and then on the next line it will be like this. And they say, how come those are equal? Well, if you square 1, you get 1. And squaring sine, and we'll see trig later, of course, but you put the exponent between the sign and the argument, not after the x. So that's where you would see that in calculus, that idea. Okay, negative exponents. So just because we're practicing pre-calculus topics, my instructions for doing a question will often say simplify and leave your answers with positive exponents. In real life, in calculus, you don't really care if the exponent's positive or negative. What you're actually looking for is the exponent to be on the top or in the numerator. So, for example, in calculus, if we had, say, 1 over x squared, we would usually write that as x to the minus 2. We don't care whether the exponent's positive or negative, just that it's not in the bottom of a fraction. That's what we're actually looking for. But in pre-calculus, we practice moving them around and just leaving your answers as positive, but it's merely for practice so that you know what to do, moving them from top to bottom. So, example, if we had 2 to the negative 1, that is the same as 1 over 2 to the 1, which is 1 over 2. So 2 to the negative 1 is a short way to write the fraction 1/2. Those mean the same thing. What if we had 2/3 to the negative 1? Well, up here in our notes, we said if we have a fraction to an exponent, that exponent applies to both the top and the bottom. So this would be the same as saying 2 to the negative 1 over 3 to the negative 1. Now, if we want to leave our answers with positive exponents, anything with a negative moves to the other side. So if it's negative on the bottom, we could move it up and make it positive. So this would be a 3 to the 1, since it was 3 to the negative 1 on the bottom. And the 2 is to the negative 1 on top. We would move that down to the bottom. 3 over 2. Okay, so go back to the start without doing any of that. What does a negative 1 exponent on a fraction mean? Look at the start right here. So the question, I put a fraction with a negative 1, and the end result here, how are they related? So we're looking for some kind of sentence to tell you what to do if you see a negative exponent. So what happens from the start to the finish? I see people doing it like this. But that's not, and I'll say English, but whatever language whatever language you think in is what you're looking for. This is not an English sentence, moving your hand. Flip. What could you say? Okay, inverse if you want to use that. I probably would say if I have a negative exponent around a fraction, I flip the fraction over. That's probably what I would say. But it has to be something that you have in your head that's not just looking at it and saying, okay, well, it looks like that. We need a word, a sentence, something for you to say when you see that, so you don't need to go through these steps. Okay, so you're looking for words for all of these. You need to say something for that rule. You don't just look at the rule, A, M, all in a bracket, N equals A, M, N. That isn't, you're not going to remember that. You need to say, okay, if there's one base and then there's two exponents that are touching, I don't know, whatever you want to say that will help you to remember, then you multiply the exponents. When there's two bases that are the same and they have exponents, we add the exponents. Right, so a sentence that explains what the rule is rather than just looking at the rule and trying to remember it. That won't work. So with our new rule, if I put 2x over y all to the negative 1, we would just say, oh, well, that's a bracket to a negative exponent. We just flip it over. You could put it to the 1 if you want, but a 1 is just a 1. You don't need it. Everything to the 1 power. So what if we did that same thing, but put a negative 2? So the whole bracket is to a negative exponent, so we flip it over. But it's not a 1 anymore. Do we have a glare? Okay, so it's not a 1 anymore. We can still flip it over. But what happens? So the negative is taken care of by that flip. And why does this work? Well, 2x over y to the negative 2 is the same as saying 2x over y to the negative 1 all squared. That was that rule that we had back here. This one. A base with two exponents that are touching. They're on the other side of maybe a bracket, but they're together. Couldn't we, going back to this rule, adding something in, couldn't we say this is n times m as well? When you multiply numbers, it's commutative, which means you can multiply either way. M times n is the same as n times n. 5 times 2 is 2 times 5. So this is sort of the why it works, is because negative 2 is negative 2 times, or negative 1 times 2. This is just a flip, and we still want the exponent squared. Now, how do we deal with this? Well, this is y squared. We square everything in the bracket. So that would be y squared, 2 squared, and x squared. So this would be y squared over 4x squared. X to the negative 3 to the 4th power. Now I'm put this one in to trick you because I want you to see all the subtle ideas. I want you to get this one wrong, in other words, because when you get something wrong, that's when you learn. You don't learn if you just get it right and you fluked into the right answer and you're not sure why you did that. You only learn if you get it wrong. So write down an answer for this one. Anything. Maybe you'll get it right, and that's good. And then I'll write one more down for you to try. Sticking lots of negatives in there. Okay, so here, there's lots of ways to do it. What I would probably do myself would be to say this. Now, I'm not saying you're wrong if you did something different, okay? I'm going to show you another way in a second. But the 2 and the x are not attached. I say that every class, and I will continue to say it. So the 2 and the x are not attached. This is 2 times x, so they are each separate. So that 4 actually is going to apply to both the 2 and the x. When there's an exponent, we multiply, so that would be 12. This would be 16 over x to the 12. Anyone get the same answer a different way? Possibly. What you could have done at the start is say this is 2 to the 4, x to the negative 12. That way, putting the 4 with each. And what you might have done is just put the negative 12 and left the 2 alone, which is totally wrong. Okay, the next one. Lots of negatives. So following what I did first here, which was I got rid of the negative exponents in the bracket first, and then I worried about what was outside the bracket. That's a good technique to not do too much at once. So if we worry about what's inside the bracket first, I would say the 2 stays on top because it does not have a negative exponent. And it's not attached to that x. Not part of it. The y moves up to the top and becomes a positive 3. The x moves down to the bottom. And I don't need to put x to the 1. And we still have a negative exponent here. It's just negative 1, so that's just a flip. Everything on bottom we put on top, top on bottom, and you could put to the power 1 if you want, but not necessary. Okay, watch out for the numbers that are not attached to the variables. Okay, so let's look at negative exponents for a second. I know we're already doing that, but I'm going to break down this. So 2 to the negative 1. 2/3 to the negative 1, so that's that is a number that's not in fraction form to a negative exponent, 2b to the negative 3 and 2b to the negative 3. So we want to look at the differences between these. All right, so the first one, right, the negative, that's 1 over 2, like that. This is a flip, 3 over 2, we saw that already, so we saw those two. Now what about this? So here, instead of just a number to a negative exponent, we have an expression, because it's a 2 times b, all to the negative 3. Put it all on the bottom, 2b, and it's now to the power positive 3. Which we could apply then to each part of that term, so that would be 2 cubed, b cubed. 2 cubed is 8, b cubed. So it would look like that. Now how is this one different? The b has the negative exponent, not the 2, and they're not attached. So what would the answer to that look like? The b moves to the bottom, but the 2 would stay on top. So this would be 2 over b cubed, and then there's nothing else to do. Okay, so be careful of what's actually in the bracket, that you're just moving that around. Okay, so here's the question. So I've already told you what to do. There's nothing new in this question. It's the last one, and then we're going to introduce radicals. So there's nothing new here, and what I already said to do is to not worry about the outside exponent, but simplify that inside first. So if anything cancels, if anything has negative exponents, you're going to deal with that first, end up with a smaller expression inside, and then worry about what's out here. So 25 over 5 is just 5. We've got an x cubed and an x to the 4. So write a big fraction here. So the x's will cancel. There's 3 of them on top and 4 on the bottom, so 3 will cancel. And how many would you be left with? 1 on the bottom. And what about the y's? Maybe you have to do this in 2 steps. There's already a y on the bottom, and this one is a negative exponent, so we're actually going to bring it down to the bottom as well. Now that 5 looks sort of out of place, but that's okay. There, we'll move it to the middle. How many y's are in here? 3. This is understood to be a 1, and you add the exponents, so that would be y cubed. And that's all to the minus 2. So what does the minus 2 do? Step 1 is flips it. and now it's squared. The flip takes care of that minus, and then everything inside is squared. So that would be x squared, y to the cube squared, you'd multiply those, and 5 squared. And that would be the answer you'd be looking for.